All righty. Good afternoon, everybody. What's going on? This your girl Tiffany coming through live in effect. And I'm happy to be here. I'm happy to see you guys. I hope everything's going well with everyone out there. And I hope everybody's being safe. So today I'm gonna get into it. As you can see the title on your screen, Emmett Chappelle. So today we're going to be talking about Emmett Chappelle, who was an African American scientist and inventor, and he was also played a factor in the NASA community as well. So what I want to do is I want to go ahead and share the information, but make sure you subscribe to the channel, make sure you share this channel, and make sure you share the video, hit the notification bell whenever I come on, all that good stuff. So again, what I do here is present a lot of facts, a lot of source of information that's dealing with Black history and all that great stuff, and get into other various topics that deal with social issues, political issues, and all. But most of the time, I'm known for dealing with a lot of Black history information. Shout out to Team Osiris. That's the research team that I'm a part of. So make sure you check out the Team Osiris channel. Okay, there's 3 of them. So there's Team Osiris on the Rise and Team Osiris. I forgot the other one. One is the original Team Osiris. The other one is Team Osiris on the Rise. Okay, and then there's a 3rd channel. So it's 3 channels that you can check out. Check out Brother Consul if you have not checked him out. Consul Sheshmu Amun. Also, you can check out the other YouTube channel, which is called Descendants of Mali, with Brother Malik and Brother Geechee. All of them, check them out. If you get a chance to, show your support and love to these brothers because they're doing their thing. All right. Now, let me go ahead and get started. Let me see some. Oh, someone put up in the comments. Hey, peace, Mr. Jeremiah. How you doing? I see you, Jeremiah. And I see that you be doing a lot. You be posting up a lot of great content. One of these days, I'm going to have to get you on here if you want to be on here. All right, so let's go ahead and get started. Okay, so this is a story of Emmett Chappelle. Who's Emmett Chappelle? So right here, according to the source, Emmett Chappelle was an American scientist who made valuable contribution in the field of medicine, philanthropy, food science, and astrochemistry. His achievements led to his induction into the National Inventors Hall of Fame for his work on bioluminescence in 2007. Being honored as one of the 100 most distinguished African American scientists in the 20th century, he was also one of the members of the American Chemical Society, the American Society of Biochemistry and Molecular Biology, the American Society of Photobiology, the American Society of Microbiology, and the American Society of Black Chemists. All right, and that's a picture of him right here. That's Brother Emmett Till. That's Dr. Emmett Till. Okay. So before I go on any further, what is astrochemistry? Let's look that up real quick, just for my curiosity. So astrochemistry is the study of the abundance and reaction of molecules in the universe and their interaction with radiation. The discipline is an overlap of astronomy and chemistry. The word astrochemistry may be applied to both the solar system and the stellar medium, or interstellar medium, the study of the abundance of elements and isotope ratio in solar system objects, such as meteorites, is also called cosmochemistry, while the study of interstellar atoms and molecules and interaction with radiation is sometimes called molecular astrophysics. The formation, atomic and chemical composition, evolution, and fate of molecular gas clouds is a special interest because it is from these clouds that solar systems form. So basically, astrochemistry is the concept of astronomy and chemistry mixed together. All right, that's very interesting. So let's just go back to his biography. Anyways, So his early life. He was born in 1925 on October the 24th in Phoenix, Arizona, to his parents, Valoda White Chappelle and Osmond Chappelle, who grew cotton and raised cattle on their farm. He was born into a segregated community. Chappelle was required to attend to segregated Phoenix Union Color High School in Phoenix, where he was the top graduate of his senior class of 25 students. Upon graduation in 1942, Emmett enlisted in the Army, where he was able to take some engineering courses before being assigned to the 9th 2nd Infantry Division that was stationed in Italy. During his time in the service, he suffered 2 non-fatal wounds in action. After his return from Italy in 1946, he attended Phoenix College, where he studied electrical engineering and received an AA degree before he redirected his focus and career towards the sciences. All right, so how he got his start in science was when he started joining the military. Okay, he enlisted in the Army, and that's when he started off studying about engineering. So he got into engineering, and from there, he showed his interest in science. So you're going to see throughout the course of history that a lot of African Americans was enlisted in the military, particularly in the Army, because the military has what is called the GI Bill, okay? And they also help pay for students to go to college and pay for their student loans and all that good stuff. So that was one of the reasons why many African Americans joined the military, is because of the income purpose, not just to fight in the wars or to be a ambassador or anything like that. It was mainly because of income. And a lot of African Americans come from the impoverished community. So they figured that was the way for them to get out of poverty and be able to pursue their dreams and their goals just by enlisting into the armed forces. All right, so let's continue. Let me see some. All right, Jeremiah, just inbox me and just let me know. All right, so let's look under career and important discoveries. Okay, so this is what he did later on in his career. In 1950, Chappelle received a Bachelor of Science degree in biochemistry from the University of California, Berkeley, then served as an instructor of biochemistry at Meharry Medical College in Nashville, Tennessee from 1950 to 1953 without graduate training. He then left Tennessee to continue his education at the University of Washington, where he received his master's degree also in biochemistry. From 1955 to 1958, he worked as a research associate at Stanford University, where he was also appointed as a scientist and biochemist for the Research Institute of Advanced Study until 1963. Then goes on, in 1958, Chappelle joined the Research Institution in Baltimore, a division of the Martin Marietta Corporation that was famous for designing airplanes and spacecraft. There, Chappelle made a major discovery that has largely contributed to the knowledge of bacteria, cyanobacteria, and other single-celled organisms around the world. He discovered that even single-celled organisms such as algae are photosynthetic, meaning they are able to convert carbon dioxide to sugar and water into oxygen. The ability to photosynthesize is characteristic of all plants. That is the opposite process of cellular respiration, which all organisms use to create the energy needed for life. Algae photosynthesis has been essential to allowing astronauts to have a constantly renewing sources of oxygen. This knowledge was not only beneficial to astronauts because it allowed scientists to develop a method for creating clean oxygen for astronauts in space, but it also provided them with a safe food source, the algae itself, that is capable of reproducing in space. That's interesting. Check this out. So in 1963, Chappelle went to work at Hazleton Laboratories, now known as Covance Incorporation, as a biochemist, but later joined the National Astronautics and Space Administration as a astrobiologist and astrochemist. In 1966, as an astrobiologist and astrochemist of NASA, someone who focuses towards the search for extraterrestrial life and studies the chemistry of astronomical objects, he worked on the Viking spacecraft and helped develop instruments to collect and scrape soil from the surface of Mars. However, he was most well known for his work on bioluminescence. In 1977, he was moved to the Goddard Space Flight Center in Greenbelt, Maryland, as a remote sensing scientist studying natural systems to improve environmental management. Okay, so then it goes on down saying some of Chappelle's most interesting work was in the area of luminescence, which is light without heat. While designing instruments for the Mars Viking spacecraft, he became interested in bioluminescence, which is warm light produced by a living organism. Chappelle developed a method using two chemicals, luciferase and luciferin, from the fireflies, which give off light when mixed with ATP, adenosine triphosphate, an energy stored compound found in all living cells to detect the presence of ATP. This method for ATP detection can be used to detect life on other planets as well as microbiological organisms. Chappelle also proved that the number of bacteria in water can be measured by the amount of light given off by that bacteria. This discovery allowed scientists and doctors to detect small amount of bacteria in places such as urine in order to detect an onset of a bacterial infection. Interesting. Additionally, he developed a method for determining vegetation health by using laser-induced fluorescence to measure the amount of photosynthesis occurring in crops, allowing scientists to detect plant stress, determine growth rates, water condition, and harvesting timing. Chappelle retired from NASA in 2001 at the age of 76. He died in Baltimore, Maryland on October 14, 2019 at the age of 93. All right. And so it shows the list of the items that he had patented, which I have some sources of information right here. Now, on July 27, 1976, method of detecting and counting bacteria. An improved method is provided for determining bacterial levels, especially in samples of aqueous physiological fluid, which method depends on the quantitative determination of bacterial on adenosine triphosphate, or ATP, in the presence of non-bacterial ATP. The bacterial ATP is released by cell rupture and is measured by an enzymatic bioluminescence assay. A concentration technique is included to make the method more sensitive. It is particularly useful where the fluid to be measured contains an unknown or lower bacteria count. That's interesting. In March of 1977, application of luciferase assay for the ATP to antimicrobial drug susceptibility, if I'm saying it right, the susceptibility of bacteria, particularly those derived from body fluids, to antimicrobial agents, is determined in terms of an ATP index measured by culturing a bacterium in a growth medium, assaying the amount of ATP in a sample of the cultural bacterium by measuring the amount of luminescent light emitted when the bacteria ATP is reacted with a luciferin mixture, subjecting the sample of the cultural bacterium to an antibiotic agent and assaying the amount of bacteria adenosine triphosphate after treatment with the antibiotic by measuring the luminescence light resulting from the reaction, whereby the ATP index is determined from the values obtained from the assay procedures. Wow, and so it goes into other listing too. Just to give you a general idea, see right here on January the 2nd, 1979, determination of antimicrobacterial susceptibilities of infection urine without isolation. That's interesting. So he's been dealing with a lot with bacteria and how you can be able to determine the bacteria in a urine of an individual, basically. So, and he studied also how some type of electricity known as basically the fluorescent can help to better detect it or whatnot. That's my understanding of this. All right, so let me go ahead and look at, so you can go ahead and look at the references at the bottom if you want to, and here's the external links down here. So let me show you some of the works that has been patented by him. All right. Oh, woo. Hello, everybody. Hello, everybody in the chat. Hello, greetings. Let me see. Greetings to Brother Bakari. Hello, how you doing? I haven't forgot about you, brother. I'll still reach out to you. Brother Jose, how you doing? Jose put, let me see what he put. Like medusas and jellyfish and some fish use bioluminescence. Oh, that's right. Fireflies. Yeah. So his work is very interesting. Basically, he studied a lot into bacteria and organism, and basically study more into urine. So I mean, it might sound weird, but it makes a lot more sense because, you know, bacteria can be anywhere. Now you got good bacteria and you got bad bacteria, right? So the good bacteria is what you need in your body because, of course, bacteria is an organism in itself. It's unicellular. It has prokaryote cells. It doesn't have eukaryote cells like every other organism. So you need that because bacteria is part of the life of an organism. Okay. It plays a main component role. So before anything else is developed, the main thing that came before the cells and the bloods and the flesh was the bacteria. So bacteria was here longer than we were. So without bacteria, we would not survive. Okay. So you got at least, you need some good part of the bacteria to keep your body functioning. But there are some unwanted bacteria that just can cause an infection. And that does not need to be there at all. So it's a great thing that he came up with the patents and the invention and study into this. So I think it's very interesting. Like I said, I got some information that I can show that proves some of his works and whatnot. So give me a second. Let's go to this one. Hopefully you guys can see the screen. Okay, let's go ahead. All right, so the United States patent on May 24th of 1983. And as you can see, that's the patent number up top. So they always got to have a patent number, okay? And of course, it says Chappelle. And this is called the rapid quantitative determination of bacteria in water. Let me see. All right, so that's the abstract down here. Okay. See if I can pull that up. All right, it says inventors Robert A. Foch, with respect to invention of Emmett W. Chappelle, Grace L. Policio, Richard Thomas, just to name a few. Okay, so as you can see, this is the abstract. Maybe I should read a little bit of it so I get a general idea. All right. The bioluminescent assay for ATP in water-borne bacteria is made by adding nitric acid to a water sample with concentrated bacteria to rupture the bacterial cells. The sample is diluted with sterile deionized water, then mixed with a lubricates mixture, and the resulting light output of the bioluminescent reaction is measured and correlated with bacteria present. A standard and a blank also are processed so that the light output can be correlated to bacteria in the sample, and system noise can be subtracted from the readings. Well, how interesting. All right, so here is the figures at the bottom, which gives a demonstration of how it was done. If you guys can see that. So I'm slowly, that's figure 3. Figure 3A. All right. All right, if you guys can see it. Okay, so now let's go down here where it says the origin of the invention. Okay. It says the invention described herein was made in the performance work under a NASA contract and is subject to provision of Section 305 of the National Astronautics and Space Act of 1958, Public Law 8556, was it 568, and was also made by the employees of the United States government and may be manufactured and used by or for the government for governmental purposes without the payment of any royalties thereon or therefore. That last part sounds kind of suspicious, but I'm gonna leave that part alone. It says background of the invention. The present invention generally relates to methods and apparatuses for rapidly making a quantitative determination of bacteria present in water. More particularly, the invention relates to methods and apparatuses for rapidly making a quantitative determination of bacteria present in water, such as wastewater, effluent, fresh water, or seawater by bacterial endocymes, triphosphate or iron, porphyrin assay. All right, so, and let's skip a little further. It says the present technique for the quantitative determination of bacteria in water employed for many years is the colony count, which takes approximately 24 hours to complete. This technique is used for testing wastewater, affluent, river, or lake bacteria contamination, estuary condition, bay water, and the like. Okay, I get it now. Now I understand. It makes a little bit more sense. All right, so basically, this was used to test to see if there was any type of contamination in water and, you know, things of that nature, such as lakes and rivers and whatnot. Okay, I can see. Now I get it a little bit better. So basically, because you have to make sure that the water is safe to use. If it's not safe to use, then therefore, you know, people can't drink it or they can't use it. So you have to check and see if the water has some form of contamination in it. All right, so now I understand it a little bit better. I had got it misconstrued a little bit. So that and that tends to happen. Yeah, but so basically it was to detect to see if there was any type of contamination in waters and lakes, such as lakes and rivers and things like that. So that's what they were basically checking for. All right. So that's one part of his invention. Let's see. I have to look up more. Somebody put, I would like to see more of his work on extraterrestrial life. I have to dig a little further to see if I can find some more information about that. I would try to see if he had some books or something like that. But as far as the information I'm presenting that I read to you guys, that's all that was available at this point. But I can dig a little more and see if there was more information about him and his whole thesis on his extraterrestrial life and things of that nature. I will have to find out more. But let's see. All right, if you guys can see this one, this is another invention that he patented. Right, it's called the ratio analysis or reflectance spectra, an algorithm for the remote estimation of the concentration of chlorophyll A, chlorophyll B, and carotenoids in soybean leaves. Wow. Let's see what this is about. Emmett W. Chappelle and Moon S. Kim, Laboratory for Terrestrial Physics, NASA Goddard Space Flight Center, Greenbelt, Maryland. And James E. Mamerturi III. All right. And also, this comes from remote Sin Environment, and it was written in 1992. So let's just go ahead and let's look at the introduction. So the introduction say the reflectance spectra of vegetation in the photosynthetically active radiation region of the electromagnetic spectrum is the manifestation of the light absorption maxima of the different plant constituents. The pigments make the greatest contribution to the light absorption in this region are those who are immediately involved in photosynthesis, namely chlorophyll A and B, and the carotenoids, if I'm saying it right. The absolute and relative concentration of these photosynthesis pigments dictates the photosynthetic potential of the plant. That is, its efficiency in the utilization of PAR for biosynthetic purposes. It thus follows that changes in the concentration of these pigments would relate strongly to the physiological status of the plant. In addition, the fraction of absorbed PAR at the canopy level is a function of the sum of the concentration and, more precisely, the molar extension of chlorophyll A, chlorophyll B, and the carotenoids. Thus, the estimation of individual pigment concentration would permit to be expressed as function of the concentration of the individual pigments. All right. Now let's see the experimental methods right here. Okay, so it says the investigation necessary for the development of the algorithm were conducted on greenhouse-grown soybeans. The plants were grown in perlite with the necessary complement of nutrients and optimal for soybean growth, with the exception of nitrogen. The nitrogen concentration was varied between three groups of plants to produce a range of physiological differences and reflectance spectra. The nitrogen concentration uses were 2 times 10 to the negative third m, 1 times 10 to the negative third m, and 5 times 10 to the negative 4 m. These concentrations are considered to be high, medium, and low, respectively, for optimal soybean growth. All right. And then it goes on to say the plants were allowed to grow for 6 weeks after germination. The following measurements were then made. 1, the rates of photosynthesis. 2, the reflecting spectra of the soybean leaves. 3, absorption spectra of the intact leaf extract of the leaves, and solutions of pure chlorophyll A, chlorophyll B, and beta carotene. And 4, the spectral photometric determination of the concentration of chlorophyll A, chlorophyll B, and the carotenoids after extraction from the soybean leaf. Now that's interesting. So I'm not gonna read any further into this. If you want to check this out, you can look on the website up here. I got it highlighted for you. All right. It is pubag.nal.usda.gov. Again, that's pubag.nal.usda.gov. All right. So you can check this out. This is the article. All right. And it got the references at the bottom. Okay. So this is another work of Emmett W. Chappelle. Okay. And it was the research on the soybean leaves and the chlorophyll and those type of things in nature. So yeah, that's dealing with more of like, what is it called? That's more like botanical work. Like botany, that's the term I'm looking for. Botany. Botany is the study of plants. So basically, in this case, he was studying the plant's life, and basically the chlorophyll of it means like, the shading, the color, and things of that nature. All right. So yeah, I'm not a big scientist type of person. So as you can tell here, but yeah, I'm just presenting the source. That's all I am doing. So if you want to look up more information, again, here's the article here. And, on your own turn, you can research it up for yourself if you got the time to. All right. Let's see what else I want to show. Let's see what y'all talking about. Have I heard of fetal transplant? No, I never heard of fetal transplant. You have to tell me what that is. What is a fetal transplant? I never heard of that. I never heard of fetal transplant. Now you got me curious. That's something I have to look up. A fetal transplant. Never heard of that. That sounds interesting. That sounds really interesting. It really sounds interesting. That sounds interesting. Fetal transplant. Nah. Jose, you might have to explain that to me. Because it sounds interesting. It sounds pretty graphic. A fetal transplant. So, wait a minute. So that's the transplant. Basically, it's artificial. Okay. I don't even want to imagine it. Well, you know what? I'll look that up later. Let's just put it like that. I'll look it up later. Wow. All right. So the last source is dealing with the NASA Technical Report Server. Okay. And as you can see here, this is coming from the archive.org. So you can also use archive.org if you want to look up more information on various subjects, whatever subject you're curious about. I normally use this as to be able to back up references and other sources and stuff like that. So this is one of the most reliable websites to go to, archive.org. United States Patent Chappelle, methods for determining surface coverage by material exhibiting different fluorescent properties. Now, by the way, I'm not a fan of fluorescent light. I don't like fluorescent light. I cannot. it's hard to concentrate. It's hard to read in those kind of light because they're very dimmy and they're not bright enough to me. So, but anyways, let me try to zoom this up. All right, so here's the article right here, and this came out in 1995. And again, that's the patent number. You gotta always, anytime you invent something and you want to get your invention patent, you gotta have a patent number so they can know and identify it is your invention. All right, and that's the year they came out, the date. Okay, so let's go. All right, so as you can see, this is the features of figure. Ooh, I don't know how that happened. How did that happen? Oops. Give me a second, guys. I'm trying to get back to. All right, here it goes. So, anyways, this is the figure 1, figure 2, giving a demonstration. As a matter of fact, I should read the abstract. All right, so the abstract, it says an approved method for detecting, measuring, and distinguishing crop residue, live vegetation, and mineral soil by measuring fluorescent in multiple bands. Live or dead vegetation are distinguished. The surface of the ground is illuminated with ultraviolet radiation, inducing fluorescence in certain molecules. The Emmett fluorescent emission induced by the ultraviolet radiation is measured by means of a fluorescence detector consisting of a photo detector or video camera and filters. The spectral content of the Emmett fluorescent emission is characterized at each point sample, and the proportion of the sample area covered by residue or vegetation is calculated. All right, so now let's go to the figures. All right, figure 1. As you can see, that's figure 1. All right, and that's figure 2. You see how they demonstrate the light on the object. Figure 3. Figure 4. Okay. And it says the origin of the invention, of course. Now you're going to go down to the technical field. It says the present invention relates to the luminar irradiation by a ultraviolet source of radiation, and more particularly to discrimination and quantification of cross residue, live vegetation, and soil by irradiation thereof with an ultraviolet source. All right, so it goes into the background art. I'm not going to read all of this, but right here it says soil erosions from cropland is affected by a real fraction of the land surface covered by crop residue, the non-living portion of a crop left in the field after harvest. Management of crop residues require leaving a substantial amount of such residues in place in order to minimize soil erosions. As little as 30% coverage of the soil by residue can reduce soil erosion by approximately 90%. Proper crop residue management constitutes an important soil and water conservation measure, and federal law requires the chief of the Soil Conservation Service to maintain technical standards and criteria to assure that practices employed meet intended purposes. In order to manage such residues intelligently, a rapid, accurate, or objective measurement of the amount of crop residue cover on an agricultural land is needed. All right, so that's that information. Let's see, let's skip and see what else we can find. All right, so as you can see, Okay. All right, so that's all for this source right here. And going back, it's called Method for Determining Surface Coverage by Material Exhibiting Different Fluorescent Properties. All right, this is coming from the U.S. patent, United States patent, the NASA Technical Report Server. Okay, because remember, he was working for NASA. So that's that. All right. All right. Anyways, I don't want to overwhelm you guys, but that's the information for today. That's the Black History Daily. So that's the story of Emmett Chappelle. Did I say Emmett? I mean Emmett Chappelle. I'm thinking of Emmett Till. Sorry. Woo! All right. Anyways, with that being said, I thank you guys for watching. I really do. And I also, this is one of the reasons why I do support STEM, because I believe that more African Americans need to get involved and need to be represented more often, because a lot of Black people are underrepresented. So when we hear about our folks, right, we can hear about them on the entertainment level, on the sports level, right, and on the music industry. But we don't hear enough about them when it comes to the STEM, the economics, the medical field, all of that. We don't hear enough about our people. And so this have been a very good information, very interesting. There's some things in there that I don't know. Like I said, I'm not a big science geek. I mean, I'm good in certain science field, but not in all science fields. So I'm still learning more about science as time goes on. It's really not easy, to be honest with you. It's really not an easy subject. But this is a great information. Anyways, y'all, if you guys want to share this video, you're more than welcome to do so. Make sure you share the video. Make sure you subscribe to the channel and hit the notification bell when I come on. Let's see what we... Hello, Anthony. How you doing, Mr. Anthony? Thank you for subscribing to the channel. I appreciate that. Yes, I do. So when I come on, I normally come on at around 1 p.m. Eastern time. So your time zone might be different where you guys stay at. But in my time zone, I come on at 1 p.m. Eastern time, or sometime I come on early around 12 Eastern time. All right. But the days that I'm doing it now, I'll be doing it Monday, Wednesday, Thursday, Friday, and Saturdays. So remember, Monday, Wednesday, Thursday, Fridays, and Saturdays, that's when I'm going to be doing the little broadcasting, okay, at 1 p.m. Eastern time. So make sure you guys tune in when I come on. Like I said, make sure you subscribe to the channel. Make sure you share the channel, hit the notification bells. I have many more subjects and topics to talk about. And also make sure you check out my other videos that I have posted on here as well when you get a chance to. Yeah, so it's a lot of content that I have on here. But other than that, thank you all for watching. And this is Tiffany, and I'm checking out. You all have a wonderful day, a wonderful afternoon, and stay connected. All right. And please, 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 please be safe. Be safe out here. Be safe, be safe, be safe, be safe. Okay? Because I'm hearing rumors about a third wave of coronavirus supposed to come through. I'm hearing the rumors. So please be extra careful, because we don't know when the vaccine is supposed to be coming out. Okay? We don't know when the vaccine is supposed to be coming out. Thank you, Anthony. I appreciate it. But until then, Stay connected. And if you want to look up more information on my channel, please go on my page and just look up the videos that I have. Look at the playlist. You know, if you want to get in contact with me, my email is in the About section. When you hit on my channel, go to the About section and you should be able to see my email on there. All right. But other than that, I'll reconnect with you all later. Thank you so much. All right. Thank you. Peace.